Hi guys, welcome to the dot product. So today we're going to find the dot product of two vectors, okay? So the dot product tells us if we have vector v and vector w, in order to combine those or find the product of those two vectors, v times w, we can define it as follows. So v times w is going to equal the product of the scalars a1 and a2 plus the scalars, plus the product of the scalars b1 and b2. So the dot product is going to be a number. It is not going to be a vector. So we've got to be very careful of that. So that's how we can find the dot product. Alternatively, if you use the law of cosines, you can come up with this little definition where it's the magnitude of vector v times the magnitude of vector w times the cosine of theta. So we're primarily going to be using this top definition here. So let's look at some examples of the dot product. Now, so for example, if vector v equals 5i minus 2j and vector w equals negative 3i plus 4j, remember I and j are vectors, find each of the following vectors. So we're going to do vector v times w, okay? So what I do is I'm going to take my a values for my horizontal values, okay, and then add to that the product of my b values. So what I've done here are my a values being multiplied, 5 times negative 3 plus negative 2 times 4, which gives me negative 15 minus 8, which gives me negative 23. That is the dot product of vector v times w, okay? So let's change it. Let's think of the commutative property, vector w times v. So if we switch, we go a2 times a1 plus b2 times b1. We actually get the same result. And this shows us that vector multiplication, this dot product, is the commutative property. So these two are equivalent, and that's going to be one of the properties you see later on. Okay, so part C, what is vector v times itself? Well, that's multiplying the a components twice plus multiplying the b components twice. So that's why we have 5 times negative 5, a1 times a1, or in this case, technically that's a2, but a1 times a1 plus a2 times, or excuse me, a1 times a1 plus b1 times b1. I get 25 plus 4, which equals 29. So the dot product of vector v in itself is 29. So in our last slide is just the properties of the dot product. Not much to this, okay? So properties of the dot product, u, v, and w are all vectors. We showed this in the first example. Commutative property, vector u times vector v, is the same thing as vector v times u. Associative property here, look, we can, or just distributive property, excuse me, is equivalent to, so vector u times the quantity of vector v plus w is equal to vector u times vector v plus u times w, those vectors. The 0 times any vector is going to be 0, okay? Vector v times itself, which we saw in part C in the last example, you could just square its magnitude and get the answer, okay? And the last one, if you have a scalar c times u times v, that's equal to c times u times v, which is equal to u times c times v. So it doesn't matter, this last one doesn't matter where the scalar is. You can combine it any way and you're going to get the same result. So that's just a rough overview of the dot product and how to multiply two vectors together. Remember, when you take a dot product of two vectors, you are going to get a number. It's not going to give you another vector. If you have any questions or comments, you can type them below and we'll see you next time.